For today's class, we're going to see divide and conquer strategy. So what is this divide and conquer? So divide and conquer is an algorithmic strategy to solve a problem. So when you have a problem of large size, it is easier to solve smaller problem instead of solving the larger problem at a stretch. So basically, in divide and conquer, you divide the problem into smaller problems, solve each of the sub-problems, and then combine their solutions to get back the original solution. So that is what are these 3 points. So the first point says that you'll have to divide the problem into equal instances and of smaller instances, and secondly, you'll have to solve them by the process of recursion. We'll see how. And the third is combining of all the solution, you'll get back the original solution. So now look at this flow chart. So you have a problem of size n that is divided into sub-problems here, each of size n by 2. Then you obtain the solution of sub-problem 1 and sub-problem 2. So on combining that, you'll get the original problem's solution. So we use recursive algorithm to solve this. And then so the few examples are, you have sorting, and you have binary tree traversals, you have binary search, multiplication of large integers, matrix multiplication, closest pair, and convex cell algorithms. You'll see examples one by one in the next slides. So before going into solving problems, you'll have to understand master theorem. So what is master theorem? So we'll see there's a formula to calculate complexity for every problem we solve. So what is this complexity? So complexity, we have two types of complexity to analyze an algorithm. We have time complexity and we have space. Time complexity deals with the amount of time an algorithm spends in solving, and space complexity deals with the amount of space that is occupied by an algorithm. Alright. So now, for all divide and conquer strategy problems, we'll have sub-problems. So to calculate the time complexity of problem of size n, represented as t of n, is equal to a into t of n by b. So b here is the size of the sub-problem, a is the multiple of sub-problem, and f of n is the time spent in combining these sub-problem solutions. So the master theorem states that when you're going to compare a and b power d, if it is lesser, you have n power d, theta n power d, and if it is equivalent, you have theta n power d log n, and if it is greater than bd, you have n power log ba. So we have few examples here. So here 4 represents multiple and 2 represents sides. So these are the solutions. So the first problem we are about to see is merge sort. So what is merge sort? It's a technique to sort numbers together. So I will divide my problem into a sub-problem. So I'm going to minimize in such a way that my problem is going to be reduced to the size of 1. So I'm going to divide, if I have 10 elements, I'm going to divide it into 10 sub-problems, each of size 1. So that is the concept I'm going to use. I'm going to divide my original problem into sub-problems each of size 1. I've reduced my problem into a very small size, say 1. After reducing it, I'm going to combine them, sort them, and store it in an array. So this process is going to be repeated. Now listen, I'm gonna initially divide it into 2 halves. Say I have an array of size 0 to n minus 1, means I'm gonna split it into 2 halves and I'm gonna place it in arrays b and c. Now recursively I'm gonna solve b and c. Say you have to see the steps here. So you'll have to compare the elements in each of the arrays, and then smaller of the 2 will be placed in a corresponding position. So you're going to do the normal sorting process here. We'll see the algorithm of merge sort. So we're going to eventually divide our problem into 2 instances. So there it goes. My a, that is of size 0 to n minus 1, is divided into 2 sub-problems, and store it here. So starting from 0 to n by 2 represent my left half, that I'm going to store it in B, and n by 2 to the last element represents my right half. I'm going to store it in C. Now I'm going to recursively sort my left half, so that's why I'm going to call the function merge sort B of 0 to n by 2 minus 1, and then I'm going to recursively sort my right half, which is C of 0 to n by 2 minus 1, and finally I'm going to merge the solutions of both B and C to obtain the solution of the problem A. See, let's see the actual pseudocode here for the sorting process. So merging process, I'm going to have two solutions. One is the solution for left half and the other is the solution for right half, and I'm going to combine them back again to A. So it is of size n minus 1. So I'll choose whichever is lesser and I'll store it back again in A, and I'm going to increment. I'm going to pick an element from left half, I'm going to increment my I index by 1. If I'm going to pick an element from the right half, I'm going to increase my right index by 1. Alright. Finally, I'm going to get back my solution. So the complexity is as follows. Let us look at a problem so that you can better understand. So if you look at this problem here, you have an array. So we have numbers. How many numbers we have got here? I guess 8 numbers. So we're going to divide it into 2 equal halves at first. So I'm going to divide it into 2 arrays, each of size 4. So there goes my left half, and there goes my right half. Alright, now I'm going to split it further. Okay, I'm going to divide my 4 size into 2 size element and 2 size element in my left, and again 7, 1, 5, 4 is split into 7, 1 left half and 5, 4 right half. Okay, I'm going to still continue this because I want my subproblem of size 1. So I'm going to divide my 8, 3 as 8 and 3, and 2 and 9 as 2 and 9. 2 is left half and 9 is right half. 7 is left half and 1 is right half. So we have split it, or all the elements each of size 1. So now for the one problem, how many subproblems we have? 8 subproblems. 8 is a subproblem of size 1, 3 is a subproblem of size 2. So we have divided our problem into 10 subproblems. Now we are going to combine it by sorting. So I'm going to proceed from the leftmost corner. So when you take 8 and 3, so 3 is smaller, so I'm going to pick an element from there and I'm going to place it back, combining it. So after that I don't have any element, so whatever is in my left I'll copy it back. So 2 and 9. So the lesser is here 2. So I just pick that element, and if I see if there is any more element in my left half, I don't have any more element. So I'm going to bring back my 9 and store it. So 7 and 1. So 1 is smaller, I'm going to take that element. I'm going to check if there is further more element in the right half. No, there is no any other element there. So I'm going to copy back my left half. So the last set, I have 5 and 4. The smaller is 4, I'm going to take that. I'll check if there is any more number in the right half. No, I'm going to copy back my left half element 5. Alright, still we can combine because we do not get the original problem. We can combine. Now I have 3, 8 as left half and 2, 9 as right half. Okay, let me pick the first element 3 and 2. So 3 and 2, which is smaller, here 2 is smaller. Okay, I'm going to put that in an combined array. Okay, I'm going to put it in 2. Next, I'll have to check it again in right half. 9 and 3, which is smaller now, 3 is smaller. So I'm going to put my 3 here. So I'm taking from left half, means the next element also I'll be taking from the left half. So I'm going to take 8 and 9. The smaller here is 8. I'm going to store it back here, and then 9. Okay, similarly in the right I have two arrays, left half 1, 7 and 4, 5. So I'm going to compare 1 and 4. The smallest is 1, so I'm going to pick that, and I'll keep proceeding with the element next to it. 7 and 4 I'll take. So 4 is small, 4, so I'll have to further take only the right half. So 5 and 7, 5 is small, so I'm going to put it back, and then I'll copy back, and I'll check if there is any other element in my right. No, so I copy back my 7. Okay, now final combining. So I'll check 2 and 1. 1 is smaller, so I place my 1 there. So I have to take the next element only in the right. 4 and 2, which is smaller, 2 is the element, so that is in the left. So I'm going to take 3 and 4. 3 is smaller, I'm going to place it, and then 4 and 8. 4 is smaller, I'm going to place that, so I'll have to take from the write only 5 and 8. 5 is smaller. 8, then comes my 8 and 7. 7 is smaller. No other element left in the 8. So I just take back my 8 and 9 and I place it here. So this is the concept of merge sorting.